Okay, guys. Good morning. Hope you had a good week. Bit of a strange week, isn't it? Working from home, but I hope you're doing okay. I thought I'd just get straight in with just to show you again how to use OneNote. I know a lot of you are using this effectively now to upload your work, but I just want to show you again how to do this. So this is our OneNote page. Now, some of you may be in different OneNotes for different subjects, but you find that's our maths one there. Annoyingly, I've put the initials wrong of myself. Now, basically, in this content library, yours will look slightly different. I can see everybody's page. You can only see your own. But in the content library, that's where I'm going to put the lessons. So today's lessons in here. And then what I want you to do is to upload your work into your area. So if I look, for example, at Emily here. So Emily's got two things here. She's got classwork and homework. Now, I've actually put Emily's work in there for her. She sent me an email. But please, from now on, put the date. So it'll be the 27th, sorry, March. And then hopefully Emily can now upload that. The best way to do that, picture from a file, or you can take a picture directly if you're using an iPad or something like that. Or if you've saved it as a PDF using Cam Scanner or something like that, you insert it as a printout. And then you find the work there, you double click and it opens up, and then it will open it up and it will look quite nice. It won't be a link there. So please do anything you do in addition to classwork. You might be doing extra work at this stage, please upload onto your page as well, so it's all together and then it's not going to get lost. Now, in terms of sort of what you're expected to do over Easter, you are going to get a bit more clarity on that. I know it's a little bit, you don't really know what's going on. To be honest, neither do we at this stage. We're still waiting for government advice on that. I think at the time being, just keep doing what the teacher asks of you. That's all you can be expected to do. If you go above and beyond that, great, but don't feel like you have to go too crazy. There will be a little bit more clarity for you, hopefully before the Easter holidays. So you know what you can do and what's expected of you, and hopefully that will offer you some closure, and there'll be an end date to when this finishes. But for the time being, just stick with it. You're all sending in some great work at the moment, so just keep doing that, and then we'll assess it from there. So that's the sort of plan of action. But certainly don't feel stressed or worried about it at this stage. You'll get more clarity later on. Right, okay, let's get straight in with the lesson then. So I'm going to come off the screen now. I'm going to give you 10 minutes. So can you get your books out? Again, everything you do, so please, when you're submitting your work on OneNote, please submit this as well. And off you go. Okay, that's about time, guys. Can you please mark your own work? First one we should have got, yeah, there you go. And then the second one, it's a binomial distribution. It's a hypothesis test there. Again, give yourself a mark out of this is just worth 1 mark each, really. And then the last one, we needed to differentiate it, work out the gradient of the tangent, and then work out the gradient of the normal and plug it in. So just give yourself a bit of time to mark that. Do feel free to pause the video if you need to. Okay. Right, today's lesson, it's a bit of a sad lesson in some ways because it is the last bit of teaching I have to teach you guys. This is the last bit of knowledge I'm about to to give you. So it's a little bit sad. I'm a bit sad it's have to be through the computer screen. It would have been much better to deliver this in person, but here we go. And it is, we did skip this, but we're going to come back to it. It's vectors and projectiles, okay? Vectors and projectiles. And it's on page 165 of the mechanics book, and it's the last bit of learning, and the date is the 27th. Okay. Oh, make that a bit later. Okay. Right, and we're going to go straight in with an example, and I'm going to use the example from the book just so it's easy for you to see. So it says a ball, and you can have this out in front of you on page 365. A ball is struck. It has a position vector of 20j. Basically, we have a situation like this. It's shown in this sketch. It starts here, the ball, 20 meters above the ground, and then it's hit. So it has a velocity vector of 5i plus 8j, and I think it's a tennis racket or something. Yeah, tennis racket's hit this ball there, and it's hit at this point here, and what's going to happen is it's going to form a sort of projectile motion. So it will look something like that, and obviously the ball's going to land there. Okay, and now it does say it leaves A and ends at B. Okay, that's it. Does it give you any more information? No, so that's what's happened to begin with. Question A is find the speed, which is important to note, 1.5 seconds after the ball is struck. Okay, so find the speed 1.5 seconds. Now this sort of question is different to what we did last lesson because we've got constant acceleration here. Constant acceleration. There's no equation in terms of time. Now, if you've got constant acceleration, you are allowed to use the Suvat equations. So constant acceleration, use Suvat. How it differs from last lesson is last lesson we had equations in terms of t, but today it's constant, which is good. And the only difference here is we just need to do a Suvat in vector form. Well, we can do a Suvat for the i's, okay, and we can do a Suvat for the j's. Now I'm going to start with a j motion, that's the up and down. Now after 1.5 seconds we don't know where it's going to end up, so we don't know where it ends up. We know the initial speed is 8. Final speed, well that's what we're after, question mark. Acceleration, now acceleration is down, isn't it? 9.8, which is gravity, and we've taken up as positive because that is positive and it's going up, so it's minus g, the acceleration. Time, well it gives us that in the question, 1.5 seconds. Now i's, you may remember from projectiles before, the acceleration in the I, we're not assuming any air resistance, so it's 0. Now when the acceleration is 0, it's very, very easy. You can just do speed equals distance over time. So we don't even really need to use Suvat, we need to just use the easiest equations there. So let's go back to our J. We're trying to get V, doesn't have S in, it is V squared equals not the classic equation, the second best. V squared equals U squared plus 2AS. No, that's the wrong one, isn't it? We haven't got S Sorry, it's not that equation at all, is it? It's actually even simpler than that. V equals U plus AT. So V equals 8 plus negative G times 1.5. Okay, and we get an answer there. We'll come back to that in a second. Just tidied it up a little bit. 8 minus 1.5 G. Now that's in the J direction. In the I direction, well, the initial speed was 5. Because there's no acceleration, it's always 5. So it's 5 the whole way across. So V is going to be 5 in the I direction. Now it asks for the speed. So our vector, our velocity vector, is going to be 5I plus 8 minus 1.5 G J. Yeah, okay. So therefore the speed, I have to use Pythagoras here, 5 squared plus 8 minus 1.5 G, remember G is just 9.8 squared, square rooted, and we get an answer there of 8.4 meters per second. Okay, 8.4 meters per second. So that's the speed after 1.5 seconds after it's struck. Right, what does it say next? Find an expression for the position vector. So the position vector, which again we call R. So the position vector at t seconds. Okay, so position vector, that is S we're looking at now. So again, let's look at the I's. Again, Suva. Let's be methodical. That's what we're trying to work out. We know that that's 5, and we also know that's 5, and that's 0, and the time is t. Okay, so the I component is so distance equals speed times time, because the acceleration is 0. So in this case, the I, so R in the I direction is simply 5t. Okay. Now, if we look at the J's, again, see that. So we're trying to work out S because it's a position vector. U, if you just remind me, U was 8. V is, this is at time t, so we don't know what V is in this case. Acceleration is minus 9.8. And the time is t again. So I'm just going to call that minus g actually, just for some consistency. So R, what has S, U, A and T in? Well, this is the classic equation. This is S equals UT plus half AT squared. It might be the last time you see this, guys. RJ, that's what S is in the J component. U times T, so 8T plus half G times T squared. Okay. Now just be a bit careful actually, that has turned negative there because it was a minus G, wasn't it? Minus G. So our final answer, position vector R is equal to 5t, not I, 5ti plus 8t minus half gt squared j. Okay, so that's our position vector, which is really, really useful for the next question, C, which is find the distance OB. So find the distance O to B, which is this distance here. How do I get from there to there? O to B. Okay, right, now I know from O to B what is happening. So in the I direction is unknown. I is unknown. I don't know how far that distance is. In fact, I'll need to work that out in a minute. But I do know how far it's dropped. So it's definitely dropped 20 meters. Okay, so it's dropped 20 meters. So I know using the J components, well, in fact, I don't even need to do that. I know that this part of the vector here must be negative 20 because it's dropped minus 20. So I know 8t minus half, that's a t there, must equal negative 20. It's dropped 20. Okay. Now, if I were to solve this equation, so I'll actually get minus 4.9t squared plus 8t. I'm just bringing this all over to one side. You may just need to pause the video to see what I've done there. But I've multiplied, that's 9.8. So that's made it minus 4.9. And then if I solve that quadratic, I get t is equal to minus 1.392 or 2.995. Now, we can't go back in time, so I have to dismiss that value and I use 2.995. Now, therefore, I just need to plug into, so I know that t is that, so therefore OB, this is looking at the I component. So what do I get? It's 5t, isn't it? So the OB is going to equal 5 times 2.995, which is 15 meters. 15 meters to 2 significant figures. Okay, and hopefully, yeah, that's helpful. It's a good topic to end on this because it's quite practical. You might this is something that people do use in real life. And we will keep going with normal lessons. I'll be a little bit more clear next week on what you're going to be expected to do over Easter. But for today's lesson, I do want you to do the following work. And over Easter, do stay in touch. We will continue to do these videos so you get to see my face for a little bit longer. But do have a bit of a break. It's been a tough time for you guys. Very, very unstable. But there will be a little bit more clarity coming, so don't worry. So what I do want you to do today, for the time being, and I do please submit this to your OneNote page 166. There's 6 questions there. Let's go for questions. Let's go for the. Might make you do question 3 to 6 inclusive. Okay, 3 to 6 inclusive. Please do upload that to your OneNote page, and I'll check in with you guys at some point next week. Take care.